Hello everyone. So on the previous lesson, you have learned on distance time graph as well as on how to solve problems involving distance time graph. So today we will start the second part of chapter 7, which is the speed time graph. First things first, let's have a look at these four diagrams here. So this is from your textbook. Okay, so we have the four diagrams here which are called speedometer. Okay, so you can usually find the speedometer in front of your parents' car or motorcycle. Okay, usually in front of the vehicle. So it actually indicates the speed of the vehicle. Okay, dia menunjukkan kelajuan sesebuah kenderaan. So let's have a look at the diagram one by one. So we have diagram 1 here. The needle of the speedometer shows the speed is at 0 km per hour. So speed 0 means the vehicle is not moving. The vehicle is stationary. And then at diagram 2, the speed increases to 80 km per hour. So 80 km means the vehicle is moving. Next, in diagram 3, the vehicle increases to 100 km per hour. So initially the speed is 80 km. So now increases to 100 km. So the increase in speed here we call as acceleration. Acceleration means the vehicle will be getting faster, okay, as the speed increases. And then the last diagram, we have diagram 4. So from 100 km per hour, the speed decreases to 20 km per hour. So when the speed decreases, it means that the vehicle is getting slower and it is experiencing deceleration. So acceleration means the car or the vehicle is getting faster, and then deceleration means the car is getting slower. So let's read a bit on the textbook part here. Okay, these are the texts from your textbook. Right, so have you observed the motion of the needle in the speedometer of a car when your parents drive the car? The needle shows that the value of the speed changes when the oil pedal or brake pedal is pressed. Okay, so the needle of the speedometer will change, okay, if the oil pedal or the brake pedal is pressed here. Now, the needle in diagram 1 shows a value of 0, which means the vehicle is stationary. Now from the distance time graph, okay, the previous part, we know that stationary means the car is or the vehicle is not moving. The increase in the value as shown in diagram 2 and diagram 3 means the speed of the vehicle is increasing. The speed in diagram 4 is decreasing compared to the speed shown in diagram 3 for a certain period. So we can show the rate of change of speed of a motion, okay, by drawing a speed time graph. So this is a speed time graph, quite similar to the distance time graph that we learned, but the difference is that in a speed time graph, the vertical axis represents the speed of the motion, and the horizontal axis or the y-axis represents the time taken, and the gradient of the graph represents the rate of change of speed, which is acceleration. Okay, so gradient is equal to rate of change of speed, okay, which is change of speed over time, which can either be acceleration or deceleration. How do you draw a speed time graph? So a speed time graph can be drawn if the following information about the motion is obtained. Okay, means we can draw the graph using either one of these. Okay, if we have a speed timetable, or if you have an equation that represents the relationship between speed and time. Okay, so this is an example from your textbook. The table below shows the change of speed of Encik Azizul's car for a period of 5 seconds. Okay, so you have the time taken here, which is from 0 to 5 seconds, and then the speed of Encik Azizul's car. So we need to draw a speed time graph based on the given table. So the steps here, first we need to choose appropriate scales to represent the given speed and time. So choose your scales based on the information given. Okay, so remember that in a speed time graph, okay, for a speed time graph, the y-axis is the speed and the x-axis is the time. Okay, so choose wisely, okay, for the scales. Okay, so after you choose your scale, you plot a point to represent each pair of values of speed and time on a grid paper or a graph paper, and then join the plotted points using a ruler to obtain a speed time graph as shown. Now let's look at these questions from your textbook, Self-Practice 7.2a. Draw a speed time graph based on the given table. So make sure you use either your maths grid book or your graph paper for this exercise. Okay, we'll be doing question 1a. So you have the time in seconds here and the speed in meter per second. So right now, let's just draw out our y-axis and our x-axis and choose our label. Remember to label your y and x-axis. So for your speed time graph, the y-axis is the speed. Okay, so here put your unit as well, meter per second. And then your x-axis is the time in second. Right, your origin 0, and then start choosing your scale. So for speed, we will be using 1 unit, 2 cm to 1 unit. Okay, so you can use 1 unit here up until 8. So 1, 2, 3, 4, 5, 6, 7, 8. Please use your graph paper for this one. And then for your x-axis, for the time, we will be using 2 cm to 1 unit as well. So 1, 2, 3, 4, and 5. And now we start to plot our graph. And now we plot our graph. So at time 0, our speed is 3. So time 0, speed 3. At time 1, speed is 4. So 1, 4. At time 2, speed is 5. So 2, 5. At time 3, speed is 6. At time 4, speed is 7. And at time 5, speed is 8. Okay, so I'm not using a grid paper here, but make sure that you guys use a grid paper and then use a ruler to connect all the plot points here. So you should have something looking like this, right? It's simple, right? So please try out question 1b on your own. Next up is drawing a speed time graph by using a equation, okay, from an equation. So example 11, the rate of change of speed of an aeroplane that is landing is given by the equation of v equals to 800 minus 1600 t in kilometer per hour and t is time in hours. Draw a speed time graph to represent the landing of the aeroplane for a period of 0 to 0.5 seconds. So first step, you need to construct a speed time table as shown using the equation. Okay, so simply choose use the time taken. Okay, so the time here is between 0 and 0.5. So you can instantly use t equals to 0 and t equals to 0.5 and then substitute inside the equation to get your speed value. Okay, so V equal to 800 minus 1600t when t is equal to 0. So 800 minus 1600 times 0, V is equal to 800. And then when t is equal to 0 0.5, V is equal to 0. So you have your plot point here, 0, 800, 0 0.5, 0. So choose your scale, label your graph, and plot your points. After that, draw a straight line from the points plotted. Very simple, right? So let's try the exercise together. So this is also an exercise inside your textbook. Draw a speed-time graph by constructing a speed-time table for each of the following equations. It is given that V is the speed in meter per second and T is the time in seconds. So I'll be showing you for question number 2B. Okay, so number 2B, we have V equals to 3T, whereby the time is between 0 and 5. Okay, so simply choose 2t value and substitute inside our equation. So we need to construct our speed time table first. Okay, so first thing first, our time. So the time here, the unit is in second. Okay, so the time is in second. And then the speed is in meter per second. Okay, meter per second. Right, so t is given 0 and 5, so we can instantly use the two value, t equal to 0 and t equals to 5. And then afterwards, substitute inside the equation. So when t is equal to 0, so v equals to 3t. When t is 0, so just substitute here, 3 times 0, so 3 times 0, 0. Okay, so when t is 0, v is 0. Next, when t is equal to 5, so the same thing, substitute inside your equation, v equals to 3t. So when t is 5, so 3 times 5, v is equals to 50. And from here, we can begin our drawing our graph. So again, when you draw your graph, make sure you use a grid or a graph paper. Okay, be sure to label your graph, your axis as well. So the y-axis is speed in meter per second, and your x-axis is time in second. Alright, and then our origin. Okay, and the scale that we are using. So for time, we have 0 and 5, so we can use 2 cm to 1 unit. So 1, 2, 3, 4, 5. And then for the speed is 0 to 15, so we can use 2 cm to 5 unit. So 5, 10, 15, 20. Okay, and begin plotting according to the speed time table that we have calculated just now. So at time 0, speed is 0. Time 0, speed is 0. So right here. At time 5, speed is 15. So time 5, speed 50. So you have your 2 points. So use a ruler to join the 2 points. Right? So there you have it. You have your speed time graph right here. So please try out question number 2A as well as inside your workbook questions. Alright? So we will see each other again in the next part of the lesson.